Hello, Mishler Math students. This is section 2.4. We're going to learn how to prove things, okay? Euclid said if you add the same thing to both sides, you get the same answer. That was Euclid, not me, okay? He said it a little bit differently, but that's basically what he said is if you add the same thing, a plus if A equals C, then A plus B equals C plus B. That's basically the additive property of equality, which we'll talk about in a minute. So how do we use that? In algebra, we use it this way. Okay, we say x minus 3 equals 5, so we add 3 to both sides. Okay, that's x minus 3 plus 3 equals 5 plus 3. So we say x, negative 3 and a positive 3 cancel each other out. So we say x equals 5 plus 3 is 8. We've been doing that for a while now. We've been solving equations in this manner. So let's see how that works with geometry. In geometry, suppose we have a line here, and I'm going to make some points on this line. I got A and B and C and D, and I'm going to say A and B are congruent. Let's say A and B are 3, okay, 3, and let's say BC, it doesn't matter what BC is, let's call that 8, okay. So what we're going to say here is that given AB equals CD. Notice there's no line over top of here. It's because I'm talking about the length. I'm talking about 3 equals 3. I'm not talking about segment or segment AB. I'm talking about the length of segment AB, that's why there's no line over it. Okay, we still have some work to do on that. I saw it looking at your tests or your quizzes. Anyway, so if I add the same amount to both sides, I have AB plus BC, okay? That's AB plus BC, okay? That equals BC plus CD. Now, why is that? Well, because BC is equal to itself, isn't it? So BC plus CD, I added the same thing to both sides, BC, okay, and it's equal to itself, okay, BC equals BC, okay. So what do I end up with? Well, AB and BC, AB plus BC equals AC. This is according to the segment addition postulate. If these two are on the same line, if I add the two, they're going to be equal to the longer one. Okay, so AB plus BC equals AC. And the next one is, and I'm not making an equal sign there, so I have BC, by the same token, BC plus CD equals BD. Okay, so that's BD. And so what I'm saying here then, after all said and done, is that AC equals BD. Okay. Now I start off saying that AB and CD are equal. I ended up saying AC and BD are equal. I'm saying that this equals this. Okay. I started off saying this equals this. I ended up saying that the longer one, including BC, is equal to the longer one, including the BC. So what I've done here is I've just proven the overlapping segments theorem. Okay, I just proved the overlapping segment theorem. This is how we prove a theorem. All right, I'm going to do that one more time now, and I'm going to show you how that works very carefully. First of all, anytime you prove something, very important, start off with given. Okay, and A, B, and C, and D. And I'm just going to put a little hash mark here saying that these are given is AB equals CD. The length of segment AB is equal to the length of segment CD. So, the next thing I want to say is prove. Prove AC is equal to BD. In other words, given that these two are congruent, prove that this AC is congruent to BD. And here's how we're going to do that. Okay, we're going to do a two-column proof this time. We're going to do a statement and a reason, because everything we say has to have a reason. So let's start with something interesting here. Let's say AB equals CD. Well, where in the world is the reason for that? Well, that's what we're given. Given, see? That's my given statement right there. Given. Then I'm going to say CD equals CD. How do I know that? Reflexive property of equality. That's a shortcut that I'm going to use. And now I'm going to say AB plus BC, excuse me, AB, oh dear, I'm sorry, I made a mistake here. It's not CD, it is, let me erase that. Sometimes those things happen, folks. I'm getting going strong. This is actually BC, okay? That's supposed to be BC. BC equals BC. Please forgive me, I make a little mistake now and then. So AB plus BC equals BC plus CD. What have I done here? How is that possible? That's possible because of the addition property of equality. The addition property of equality tells me that I can add the same thing to both sides and they're going to be equal. And BC is equal to BC, so I add the same thing to both sides. Now they're equal. Then I say AB plus BC equals CD. Excuse me, AC. I really need to watch my letters here. All right. AC and BC plus CD equals BD. How do I know that? What's the reason for that? The segment addition postulate. The segment addition postulate we had in the previous chapter, it says if I add these two together, if I add AB and BC, I get the longer one, AC. So that's how that works. And finally, I can say AC equals BD. How do I know that? Because of substitution. What did I substitute? Look, AB and B plus BC is what I had here. I said that this is equal to this, right? Well, AB plus BC is actually equal to AC. So I've substituted that for that. Same thing here. I substituted that for that. Got it? So AC equals BD. That's what we set out to prove, isn't it? AC is equal to BD. Now, if this is a little confusing to you, it probably will be at first. But just remember, we took it a step at a time and we gave a reason for each statement, each thing we're doing. Okay? So, the next thing you need to know, by the way, we just proved the overlapping segment theorem, or segments. That's supposed to be segments. Overlapping segments theorem. Okay? One more thing I want to talk about here, and these are the properties of equality. Okay? And properties of equality. Oh, I love when I do stuff like that. All right, properties of equality. And properties of equality start with reflexive. We just used that one. Reflexive property of equality says that A equals A. Now that's about as obvious as they get, okay? But we still need to do that because we have to give that as a reason sometimes. Then the symmetric property says if A equals B, then B equals A. So yeah, we just turn them back and forth like that. If A is B, B is A, okay? And finally, we have the transitive property. And the transitive property says if A plus B, if A equals B and B equals C, then A equals C. Okay? That's pretty much how that works. And so those are the properties of equality. We have one more thing to talk about here, and that's the properties of congruence. They have the same three properties, except reflexive property says that this triangle, okay, is the same as itself. That's what the reflexive property tells us. Real simple, but it's still, we have to say that, okay? The symmetric property says if this triangle is congruent to this triangle, then they're congruent with each other, okay? So we can flip those back and forth. They're congruent with each other. And then finally, the transitive property, if this triangle is congruent to this triangle, and this triangle is congruent to this triangle, then this triangle is congruent to this triangle. And again, those are just three properties that tell us the things we need to know about equality and congruence. And thank you very much.